David Smith here with one more flipped classroom math video for your enjoyment. 3 tips. First, you can speed up or slow down the playback if that helps you follow along. Second, you can pause anytime to catch up with your notes or think a little harder. Lastly, you could turn on the captions, which will show you my words on the screen below. In this lesson, we're going to learn how to use a formula that will let you quickly find any term in any binomial expansion. And this would save you a lot of trouble, especially when the powers on the expansion get high. But before we do that, I want to review a few basic ideas about what we've been doing so far so that we understand the variables, how to calculate them, and then how to plug them in to find what we need to find. So check this out. So this formula you've seen before. This formula just gives you the coefficient from the triangle. Now you remember that that's not ultimately going to be the coefficient on the term because there are other numbers that end up multiplying that one. But that's a start and it's an essential part of figuring out each of the terms in a given expansion. So we've played with that one already. Now I want to talk to you a little bit about R. R is the term number minus 1. So let's think about this combinatoric situation. Let's say I have 4 items and I'm interested to know how many ways I can select 2 of them, okay? So 4 items is going to be on the 5th row, all right? So that would be our n, and I'm making a selection of 2 items. So here is 0 items, here is 1 item, and here is 2 items. This is the 3rd term. So if you're starting with the term number, you have to subtract 1 to get your R value. And that's why R is the term number minus 1. You have to remember that, otherwise you're going to go astray. Now the second thing is n is the total number of objects that we're selecting from. N is the row number plus 1. It's also the power. Now think about this. This is, the first row, is how many selections can we make from 0 items? There is only 1, and that's selecting 0 items. So that's why we have a 1 there. The second row is for 1 item, and we can either select 1 or not select 1. So this is selecting 0 items, and this is selecting 1 item. So you can see here that the row is plus 1 gives you your power, which is how many total items you have. And so I've put that over here on the second side of Pascal's triangle. And I think this is useful to realize. You don't have to draw this out every time, but the row number is the power number plus 1. So on the second row, we have 1 power to the first power, or 1 item to select from. Similarly, on the 6th row, we actually have 5 items to pick from, or we're using the 5th power. Or when you're going the other way, if you're referencing the triangle, if you have something with the 6th power, you're actually looking at the 7th row of the table. So this can get you a little bit discombobulated if you don't know this right. So there's 2 things here that you just have to keep track of. That R is the term number that you're interested in, minus 1. So if you're interested in the 4th term, your R is 3. And N is the total number of objects. So if you're interested in making selections from 5 objects, you've got to add 1 to get to the row number. Okay, so that's review. Now let's take a look at our new formula. And this one's pretty cool. This one finds a specific term in a binomial expansion. And here's what it is. It's NCR. That's just this expression here. So to figure this piece out, you've got to do that step. And you've got to remember your R is your term number minus 1. So it's NCR, and then it's A to the N minus R, B to the R. So you can see this is a pretty simple plug-in step. Now, it's going to allow you to find a specific term in a binomial expansion, like say to the 10th power. And if you had to do that and then figure out that certain term, that's a lot of steps. This one's going to get you there much, much quicker. So let's do an example. Okay, so let's use what we just went over to do the following. Find the 3rd term of x to the 3rd to the 5th power. Okay, so we know you could do the whole expansion and then just figure out the 3rd term, but let's make that process a little shorter. So first step, find R and find N. So go ahead and pause the video and do that. Okay, so r is just the term number minus 1, so our r is 2, and our n is 5 because that's the power. And so we're on this row, we're on the sixth row of the table, which corresponds to the fifth power. So our coefficient, the first part of our formula, is going to come from that row. It's got to be 10, because that's the third term in the sixth row. However, we're going to use our formula to do that, which is indeed the next step. So remember that this is our formula, so our first step is to find this one. So what we've got here is we've got 5c2, which is going to be 5 factorial over 2 factorial times, I'll just leave that out and we'll just do 3 factorial. That's that formula, and go ahead and pause the video and work that out. So I just factored the top until I got my 3 factorial, so I could cancel it through on the bottom, and then I just have 5 times 4, which is 20, divided by 2 factorial, which is just 2, so that gives me 10. And yes, it confirmed what we had said before. We should have 10 for that coefficient. So now I need to bring my 10 down into this formula here. So I have 10 times x to the n minus r. So it's n minus r to the third, and then this is going to be 3 to the r, which is the second power. So now we can pretty much crunch that down. So pause the video and see what you get. All right, so for this one, I get 90x to the third. So that's the third term of x plus 3 to the fifth power. Now, I want you to pause the video and find the fourth term. Use the same process and go ahead and do that calculation. All right, here's the first step. We need to do 5c3, so that's 5 factorial over 3 factorial times 2 factorial. You notice that this is the same as it was before, just the 3 and the 2 factorials were switched. But I went ahead and worked it. I got 10. Now look, I'm looking at the fourth term on the sixth row, and guess what? That's also 10. So we can confirm that with Pascal's triangle. Now, we need to do the next step. So pause the video and finish that out. Okay, plugging in what I know with my r and my n and my coefficient from the triangle right here, I go ahead and I get 10x to the 5 minus 3, which is x squared, to the r, which is 3, and this comes out to be 270x squared. So that's the fourth term of that binomial expansion. Now this one's definitely a little bit more complicated. I want you to pause the video and see how far you can get. I'm asking for the seventh term of 3x minus 4y to the 10th power. So obviously you don't want to calculate the full expansion on this one. If you just need the seventh term, you can use our formulas to do that. So go ahead, pause the video and see how far you can get. All right, so first off, I figured out my r, which is my term number minus 1. So my r is 6, my n is 10. I plugged that into the calculation that gives us the term number from Pascal's triangle. We get 210. Now I can't check this on my triangle because I'm not going to make the triangle to 10 or 11 rows. That's just too much. So we're just going to take that on faith. And then now I want you to pause the video and finish this. All right, let's see how you did. So basically, taking my 210, plugging it into my formula where I have 210 times the a term, the x term, 3x, to the n minus r times the y term, minus 4y, to the r. And then I simplified that on down, and I'm getting in some pretty heavy multiplication here, but this is your term. Now, if you haven't done all this math and all the calculating, get used to that. You may have a problem on a test or a quiz where this would be the answer, and you do need to be able to perform those steps. All right, now let's do a more complex example. Look at the setup on this one. They're telling us that the fifth term of this expansion, some number times x plus some number times y, to the nth power, don't know what the power is equal to 560 x to the third, y to the fourth. Now look what they want us to find. They want us to find a and b. So perhaps pause the video for a sec. See if you can figure out some things. Maybe you can't find a and b, but we can figure out some stuff from this. Okay, so we can figure out r and n. We know that it's the fifth term, so r's got to be 4, and we know that we're counting down from 7 to get here, and we're counting up from 0 to 7 to get here. The two powers always add up to n. So we know our n is 7. So now we can figure out the coefficient from the triangle that will give us part of what we're after. So see if you can do that. Okay, so check this out. I figured out that my r is 4 because I'm looking for the fifth term. So r is just the term number minus 1. And my n is going to be 7. And the way I can tell that is to just add the powers on x and y. Remember, the powers on the x always count down from n, and the powers on the y always count up from n. So when you add those two powers together, you always get n. So I just did 3 plus 4 is 7. Now I can plug those into this formula and get 7 factorial over 4 factorial times 3 factorial. That gets me 35. I can also take a look. When my n is 7, I'm on the 8th row, and I'm looking at the 5th term from my problem. So 1, 2, 3, 4, 5, 5th term. So there we go. I know that I have my 35, and that's what we got here. Now, here's the next step. It's kind of strange, but basically we know that the 35 has to go on the x component of this. So now I can write 35 x to the third y to the fourth. Now I have to know something about this. To make whatever component goes in front of the y, it has to multiply to make 560. It has to multiply by 35 to make 560. So 560 divided by 35 is going to give me what goes here. And that indeed is 16. So now I can write 35 x to the third, 16 y to the fourth. Now, we're not quite there yet because I need to find out what the b is. Now the b is inside of my parentheses, so it's acted on by the power. But right now it's not. I have y to the fourth and 16 outside. But 16 is a really nice number for this. It's a power of 2, and coincidentally, it is the fourth power of 2. So I can write 2 to the 4 equals 16. So this is cool because now what we can do is we can write 35 x to the third parentheses 2y to the fourth. 16y to the fourth is the same as 2y in parentheses to the fourth. Okay, so the last step, again, is a big critical thinking step. Check this out. Here's the form of what we're doing. Now, we know that it looks like this when it gets all multiplied out, but it's going to come from one of these. So here is our b, because that's being acted on by the power, and our a is this 1 that's right inside here. You could write this as 35 times 1x to the 3. And so that means that our binomial that we're expanding is this one. Okay? And actually we know it's to the 7th, so we might as well put that up there. So that's the binomial that we expand to get all of this stuff that we've just calculated. We've just gone at it backwards. So we found our binomial. The 5th term of this expansion is that. We just reverse engineered it. So let's cycle all the way back around. It said find a and b. So if you look at this form here, and you go compare it to there, you'll see that a equals 1 and b equals 2. So that's what they were asking for in this problem. Okay, one last more complicated problem. Here we go. It's an interesting binomial now. We have x plus 1 over x as our binomial. Okay, so check this out. 4x plus 1 over x to the 9th power. Find the term in x to the third. Now, that's kind of a weird prompt. We haven't seen that yet, but I'll simplify it out for you. All it means is find the term that has x to the third in it. That's all. We're up in the 9th power, so we know we're going to probably get a term with x to the third in it. So there's a couple ways to do this one. This one's not overly complicated in terms of calculating. You just have to look at this function and see how it goes. So let's check this out. I'm going to do this way. First term. What is that? That's going to be, according to our theorem, it's going to be x to the 9th times 1 over x to the 0. We're just counting down. We're just using our binomial theorem. And so this is just going to be x to the 9th. Okay? Our second term, we're just going to count down. So this is going to be x to the 8th times 1 over x to the 1. So this is x to the 8th over x to the 1, which is x to the 7th power. Okay? Let's do the third term. We're getting close. This becomes x to the 7th times 1 over x to the 2nd, which is going to be x to the 7th over x to the 2nd, which is going to give us x to the 5th. And so now I think you can see the pattern. We're just going down by 2 every time. So the fourth term is going to be x to the 3rd. Okay? Now, we're not done. We know it's the fourth term. Okay, so that's going to give us what else we need to find the full term. We know it's the fourth term. So what's r? R equals 3, and n equals 9. So what we've got is the 9th row. Okay, we don't even have that on our triangle, so we're going to go ahead and use our formula. NCR equals 9 factorial over 3 factorial times 6 factorial. Do the math on that and come back. Okay, so when I crunch the numbers on that, I get 84, and then, so this gives me this term, which is the term with x in the 3rd. They didn't even tell us what term it was. Turns out it's the fourth term. So the fourth term of that expansion is 84x to the 3rd. All right, now that you've watched the video, take a minute and jot down any remaining questions so you can bring them to our next class. Also remember, you can watch the video again. Maybe that will deepen your understanding. If you like the video, please click like and subscribe.